Hey everybody, we are back and we are doing some more geometry. Welcome to Welch's math class. We're going to have a good time here this fine day, doing a little bit of geometry, having some fun with some math. Okay, so we are in section 8.8, the Pythagorean Theorem. That's Pythagorean, Pythagorean Theorem. Now, let's talk about what the Pythagorean Theorem is used for before we get into the actual theorem itself. Let's start off with what we'll call, or what is, right triangles. Right triangles. Okay, so let me give you a couple of examples of a right triangle. So we've got this triangle here, and notice that one of the angles is a 90-degree angle. There's one example of a right triangle. I'll give you a couple more examples. We could draw the right triangle more like this. And here's my right angle, a 90-degree angle. We don't know what the other angles are. We could draw it out like this. And here's the right angle. So the Pythagorean theorem would work on any of these right triangles. It's specifically a theorem that works with right triangles. Now, with right triangles, we need to label some pieces so you'll know what we're dealing with a right triangle. We'll just label this one right here, this larger one. The sides that come off the right angle right there on the right triangle, these are called legs. Okay, legs. On this one, this would be a leg, and this would be a leg. On this one, this would be a leg, this would be a leg. Okay? The side opposite the right angle, which by the way is always the longest side in a right triangle, is actually called the Hypotenuse. Hypotenuse. That's called the hypotenuse. It's the side opposite the right angle. All right? Very important that you get hold of the idea of what the legs are coming off the right angle and the hypotenuse opposite the right angle. So on this one, this is a leg, hypotenuse here. On this one, a leg, the hypotenuse here, because of the way they're positioned. Okay, so what the Pythagorean theorem does for us, what it does, we can simply say, given the lengths of two sides of a right triangle, we can find the length of, I'm running out of space there, of the third side using a square plus b square equals c square. This is the Pythagorean theorem formula. And we'll call this on our right triangle leg A, leg B, hypotenuse C. Leg A, leg B, and hypotenuse C. So essentially, if we square leg A, square leg B, okay, square leg A, square leg B, add those together, and then take the square root, we'll have the length of the third side. This is the basic formula that we're going to use to find the length of the missing side of a right triangle. Okay, let's put that into practice for ourselves. Make sure you get this copied down. I want to give you an example of how to use the Pythagorean theorem to work a problem for yourself. All right, so let's take a right triangle. Okay, so here's our right triangle. All right, so what we want to do is, let's say we're given the length of two of the legs. Let's make this leg right here 4 inches. Let's make this leg right here 3 inches. And what we don't know is the hypotenuse C equals question mark inches. Question mark inches. And so what we're going to do, guys, is we're going to use our formula, a squared plus b squared equals c squared. Okay? So leg A over there is 4 inches, so we're going to go 4 squared. Okay? This is leg A. This will be leg B. 4 squared plus 3 squared equals c squared. All right, so far so good. What's 4 squared? You got it, 16. Yes, 16 plus 3 squared, of course, is 9 equals c squared. 16 plus 9 now is 25 equals c squared. Now, our final step here is that the length of the missing side is not 25. Actually, what we're looking for up here is c. What we have right here is c squared. So all we want to do is take the square root of 25. So we'll end up, if we take the square root of c squared, that'll be c. The square root of 25, that'll be 5. And so the side, the length of the missing side is 5. 5 inches. 5 inches using the formula. Now, I have a shortcut for that. If you'd like to take a quick look at it, you've got the formula down. You see how the formula works. Let me share with you a quick little shortcut that makes use of the Pythagorean theorem for what you're doing here. Our quick little shortcut. Given 2 legs, but missing hypotenuse C, or just hypotenuse. All right? Let's spell that right. All right, so if I give you the 2 legs, let's put one up here. Here's a new one. This time we're going to situate it a little different. I'm going to give you this leg right here is 9 feet. I'll give you this leg right here is 11 feet, and we're not sure about the hypotenuse. So our shortcut, making use of the Pythagorean theorem, is 1, square the legs. Okay, so we'd be talking about 9 squared equals 81. 11 squared equals 121. So the first step is square the legs. Second, add these. Okay, so 81 and 121 is going to equal, we'll just say add these, so we'll go 81 plus 121 is going to equal 202. 202. And our last step is square root. Square root. And so we're going to take square root of 202. Ooh, I think I'm going to need my calculator for that. Now don't forget to round these off when you do it at whatever place the computer asks you to round it off. So I'm going to go square root 202. Okay, 202 square root. 14.21267. Let's round that to the nearest tenth. So I'm going to call it 14.2. 14.2. So given the length of this leg being 11 feet, the length of this leg being 9 feet, using our Pythagorean theorem information, we see that the length of the hypotenuse is 14.2, and that's feet. Since it's a linear measure, we're not measuring an area, so it's not square feet, not measuring a volume, so it's not cubic feet, but it's a linear measure from here to here, 14.2 feet. That's rounded to the 10th. Okay? All right. Now I want to do one more thing with this. Give you one last little bit. This is also, what I'm about to do is another shortcut, also based on the Pythagorean theorem. okay, based on the Pythagorean theorem, but just a little shortcut. Not always are we given the length of the two legs. Sometimes we're given the length of one leg and the hypotenuse, and we have to find the length of the other leg. So in this case, we're going to say given one leg and the hypotenuse. Okay, so given one leg and the hypotenuse. Let me give you an example of what I'm talking about. So let's say we've got this right triangle right here. Here's my right angle. And let's say that this leg here, what do you want to make that leg? How about we make that leg right there, let's make it 8 inches. And we don't know maybe this leg, this is my question mark, and so beyond that, my hypotenuse, let's make my hypotenuse over there, that looks like that's about, let's make it 14, 15, let's make that hypotenuse 15 inches, okay? So if we made that 15 inches, here's what we're going to do. It's going to be similar to what we did before. We're going to start off, step 1, square. If I could remember how to spell square. Square the given sides. Okay, so we'll do 8 squared equals 64. 15 squared equals 225. Okay? Now, here's where it gets a little different. Instead of adding these two together, in step 2, we're going to subtract these. So we'll be 225 minus 64. Now, gosh, I wonder what that is. I might have to pull out my handy-dandy calculator. See what I got. Alright, so 225 minus 64 equals 161. Alright, so 161. And then finally, my last step, take the square root of 161. So I'm just going to punch in, I got my 161 in there, I'm going to punch square root, and I'm looking at 12.688 something. If we round it to the 10th, 12.68 will be 12.7. Okay, so equals 12.7 inches. And that perfectly makes sense here when you look at this. 12.7 inches. Of course, this side looks a little longer than that side, so it should be a little longer than that side. And of course, the hypotenuse is always the longest side on this thing. And so there you go. So now, guys, you know how to use the Pythagorean theorem to find the length of a missing side in a right triangle. It doesn't work with other triangles, only right triangles. And so you can do that. That will show up in your homework in 8.8. Also in 8.8, there is a piece there that talks about something called similar triangles, and we'll save that for another video. I know you're excited. So we'll see you back to talk about proportions and similar triangles next time. All right.